Hello, welcome to another video where I'm slowly working through an operating system slash assembler project. Um, so I believe the last video I was talking about kind of setting up a hole to fill a label like such that can then, once you find the label in the source code, it can go back and kind of overwrite everything that you have. And I believe I have, or no, where did it go? It went in this test file. So I've got some tests that kind of show off various use cases of kind of forwards and back referencing labels and kind of making sure that the output is as expected, I guess. And it only does it over a jump at the moment, but theoretically it could happen for more things. In particular, this next instruction will probably hit it because this will become a whole. And I believe we can kind of check that if we run that. Yeah, that is actually exactly what I want. In fact, the current make is that, and yeah, it's unhandled token open bracket. It doesn't know what to do with an open bracket, and perhaps we'll make it know that shortly. But after it gets the open bracket, it will then kind of have a problem. Perhaps I should bump this up a bit, and if I do debug, it doesn't do that because it can't like even tokenize it. That's a little frustrating because I kind of want to see what it tokenizes this as. I would assume that it kind of tokenizes as a oh, I didn't want to do that one. What we'll do is kind of just restart things and do that. And what I think I'll work on is actually in this test file, the move. So what I want to do is basically make it so I can do some more advanced moves. Because in if we go to mine, in mine, I don't actually have that many exciting moves. I've just got one type really, which is just moving 8-bit value into a register. In doing so, I actually made it so it worked for 16-bit as well. I've condensed these tests up a bit because the instructions kind of get encoded in this kind of way. So, and that's the opcode, and then it kind of goes up by the destination, and that kind of shows roughly how it's meant to be working. And we have like registers in this particular order, and then 16-bit registers in that particular order, and do that. And so now what I'm doing is the next stage of kind of getting something like this to work, and perhaps I'll get rid of the debug for now. And actually, no, perhaps I will have the debug. So what I'm trying to do is basically move DL into BL, and so it will detect BL and DL as identifiers. It works out later that they are actually registers, which kind of might mean that you can do some funky things like set that to a thing, and then maybe it will do a different thing depending on what it is. So perhaps I need to kind of make it more apparent in the tokenizer what they are. That might come a bit later. But currently we check in move for a particular thing. So we can say do that, and it'll give me an assembly of that, but it doesn't know how to do that. So basically, move has a few different opcodes. So this is a nice little website. he has pretty much just all of the instructions in a kind of nice-ish way to read it. This is kind of what I read last time when I was doing the operating system project that I did last time. Reboot, and now I'm doing an assembler, and this is kind of handy because it gives you the opcodes and kind of how it's meant to be encoded. So the one that I've done is basically this one and this one, and perhaps that one I can't recall. But it looks like I don't actually have tests for that. Yeah, I haven't done like EAX and RAX and whatnot. And I haven't done these forms where you kind of say this is actually going to be slightly different. So, like if you're in non 16-bit mode, you can then, well, in here it says if you're in 64-bit mode, you can do these 8-bit register accesses, but you have to put in this beforehand, and you see a few others kind of have that prefix, which is basically saying the byte width of this instruction is different. But what I kind of want to do is do this thing, because I believe this is all I need for both something like this. Maybe we'll just do that. So something like this, where we have DO and BO, but it could also do something like this, where this is a memory address and that's a register. So register, and this can be either a memory address or a register. And to determine which it is, it uses something called, so the operation encoding is MR, and if you kind of scroll down, MR, it uses this mod RM. So basically it has two operands and both mod RM type things, and how it kind of encodes is how I've got these test cases. So the opcode is just 88. That's from the top there, 88. And then the next opcode is either, well, in this case, I am setting the mod to be set, which I believe means it is both the source and the destination in the same byte, and you can put both in because it's just 1 byte. And I believe if you have this set something different, you get a different thing. And I can actually kind of test this if I do TF, which is a how do you do it? I think it's something like that. So it's just a shell function that runs FASM, whereas type T takes that debug flag and does some things, but this just runs my assembler. So this way I can kind of see how FASM would kind of assemble it. And you can see here you've got that 88 in both cases, so that's got my hunch of these are kind of the same instructions. According to this, I have been told x86 is kind of a gnarly thing to encode instructions for. But you see here that this only has 1 byte and this has 3 bytes after that. So this DL, what we can do is we can kind of maybe change it to AL and kind of see how that changed things. And you see here that so compared to this one, this 16, well, actually no, that's quite funky. That's encoded a different thing. I wonder if there's, well, we can see A2. Where is this A2? It's encoded as that purely because I used AO, and it's also a memory offset. So perhaps if I change it to BL, we can kind of see that what kind of changes between BL and CL. And you see here that this byte is changing. So this is kind of encoding that value there. And this here is just 1. And you can see here that this is 1. And I did like 1337, you'll see it would get the 1337 in little Indian order. So this instruction here is 1.6, and the mod part of this is just the top 2 bytes. So it would be 0xC pretty much, which you can, I don't know, I can do 0x3 shift up 6, and I can also do a 0xC, and you see a bit different because it's actually C0, and you see they're the same. So if C0 is set, and you see here this is just 1, so this has like none of the bits of C0. In fact, so it doesn't have this kind of mod flag, which I believe means that it is just encoding this. So that 1.6, I believe if we kind of downshift that by 3 bytes, and you can see here the source is the first one, maybe that's wrong. But if we kind of look at that, we can see it is D2. I mean, might close this window. So you can see the order of the registers up there, and kind of I'm just perhaps looking at this field and this, and I can see it has a 2. And if we look at the registers, 0, 1, 2 is DL. So if we perhaps, I don't know, if we change this to CO instead, this is 0E. That's a bit different from the DL1, but you can see it's only changing this byte here. And if we get that 0E, 0E and shift it down by 3, we get 1, which we can see here is the 1. And so I guess we could try a BH, which is like the upper end of it, and it gets a 3E. And if we kind of look at that, we get a 7, which is like 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4. There should be 2 groups of 4. And so the BH, I would have thought, would be off by 1, actually. Because I guess I would think this would be kind of in this order. I'm kind of not looking at the output yet, but if we look at the CO, which was this version, 0E, then 1.6, then 1E. So these do actually vary quite a bit. So I might need to look up how these work. But there's also kind of this first bit here, which is a bit tricky. So what I thought is I would start with the easier version, I think, which is kind of this, where you have this E and you do some math, and so we worked out that C0 was the thing. I believe if you we surely can do like a not type thing, and we can not that value and then AND that thing with 0xE7, and we get 39. And I think I want to change this to printf and do that sort of thing, just so we can see what sort of value we're looking at. And so this E7, if we kind of or that we just have 2 7 left. So it kind of means that this E is set. Perhaps we want to do just that, and we can see that, yeah, both is set, and this is kind of what is left over. So this thing that is left over, what happens if we kind of AND it with the first 3 bits? So there'll be not 1, not 3, which would be 2 plus 1, but 7. And if we do that, we can see the bottom 3 bits are set, which you can see by that 7. And if we instead just shift it down by 3, we can see we have a 4. So to me, that would mean we had a 4 and a 7. And we can see what 0, 1, 2, 3, 4 we had an AH and perhaps a DH. And if I go back to what I was assembling, we had a BH and a AH. So the BH kind of makes sense because this is 8 things, so the last one is BH. And then AH was 4. Yeah, that kind of makes sense because we've got 4 there and it's 0 index, so 0 index there. So I believe I can assemble that. But currently, if we do the test suite, this will kind of fail at that move point there. Perhaps I want to put in a test for the other one, but I think I want to do just this one first. It doesn't actually get me any closer to my operating system, I guess, but it's the easier option. And I guess I can show you what the operating system does. So is there a Vim with source boot x86 bios.mine? So if we get this, and if I just comment this out, and I believe we can now just run. Oh, no, it doesn't. Might just call that disk and that disk, and then we can run. I forgot I put columns in, but yeah, we basically get it booting, and can we like zoom to fit, and we print the OK, and the OK is coming from my operating system. The other 2 messages are not. But yeah, I kind of got 2 problems there. But for now, I kind of want to just get the assembler kind of working a bit better, because now in doing this, I already have a move instruction, and you can see it kind of landed inside of this because it decided, well, we actually have a hole for the computed instruction, so computed expression. So that's the source. Perhaps this could yeah, I thought this would have failed earlier, but yeah. So this is where it's doing that kind of setting the register, which I think I want to change the token that it gets back into kind of, this is an 8-bit register, this is a 16-bit register, or something like that. Because then that way I can kind of reason about it without kind of going through in the move execution and kind of comparing the identifiers, and that way you won't accidentally have something like it. If we had some source code, we could go something like BL equals 3, and then if we do something like AL, BL, what would that assemble as? Would that kind of assemble as 3 and then AL, or would it do something different? The answer is it would currently do that. It would change it to a 3, and it would kind of ignore the fact that AL was a register. So I think that's probably the first thing I kind of want to do. So perhaps get some things. So we have basically a list of tokens. We do a lot of X macro type stuff. Yeah, you can see we've got a lot of stuff, and we already have codes for these registers. And what we do with these X macros is the first thing is the first thing kind of defines a list of things, and then down here we kind of define X to be what we want, and then that way we can define a whole bunch of enumerations and like all the strings saying what they actually are. And then like some we have like an S code as well, and then that's that. So what I think I want to do is the token. We already have an x86 instruction, so I think I want to do something like this. And we could, I think well, how do we do the other register? We do 8-bit register, something like that, and then we can find that 8 and then 8 more of that, and then boom, we've got new registers, got new tokens. And then when we do the identifier, we actually need to kind of check all the yeah, so we can do something like this. Something like that, and then we can probably just dump 2 of those, maybe just 1 of them, and then here we can this is where do we get the we do a string view and register, we do this sort of thing here. It's like a different way to kind of what I would quote, but kind of what I want to do is do a similar thing here. So x86 8-bit register T, and then we can have reg 8, and then here we reg 8. I wonder if I change this to instruction, and then we can do like an 8-bit register. Do that in a few places. And perhaps here I can also do that, and perhaps that did the thing that I wanted. So then we can probably get rid of that, and then here I guess I want to do that and that. And reg 8. Reg 8, we can do that, and they'll complain at me, which is kind of what I want to do. And then here we can just change that 8-bit to 16-bit everywhere, and then do the same like that. And just 1 second. 1 second. That's all good. Right, so we did 16-bit, and here we also probably want to do that reg 8 to reg 16, and 8-bit. So I think I want to search for 8-bit register, that thing, and then that's reg 8, and then that's like that, and then here I want to do the same for this in reg 16 and do that, and I think that will kind of do all the things that I want to do, and then when we had this. So here we won't do this. So this will actually break some other tests as well, I guess. But it will also not compile because I have all these static asserts, which might seem irritating, but it's actually kind of handy because here I need to add something related to this because the token I actually added the x86 8-bit register T and we did a reg 8 and we also did reg 16 and so boom my compiler took me there, and if I do it again I only incremented one, but we added 2 tokens. If I do it again, we get to here. And do I need to free anything? I do not. They just got assigned an enumeration. What about in this? We're parsing an expression. I think that should be so that would be if we had something like I don't know AH and then BH plus 3. I think like you can do some kind of spooky stuff with like I can do like 3 times BH. You can do like stuff like that. I think with one of these like weird things. I don't know. I'll come to it. But I think for parsing an expression, I think I don't want that. And when we parse the mob, we actually parse kind of 2 expressions. So yeah, maybe I do want the expression to be that. So it will still kind of compile, but if we look at the mob T, we just kind of say an expression is the source and expression is the destination. So I think I do want to kind of make some new expressions, probably. So here it kind of just lets you do that. Beeps and whatnot. I need to check up on all my beeps and whatnot. That's all right. Right, so for the other stuff, we kind of just do it as a thing, which means you can do spooky things like this, and then you can like move AH and then log plus 3. And I think this will, can we set make PRG equals ASM and this test file things. We're not allowed at the moment. But I think this will kind of compile. Maybe I'll keep it in there and see what happens. So what do I kind of want to do if it is a... I think I want another expression type that just says it is a thing. So that's kind of like the same way that we kind of added these. I now want to kind of add these, and then like it kind of just blows up. And then it will probably want something like this as well. I think that's kind of so when we have an expression, I think we'll kind of want these same 2 things to kind of float along with us. Same with a computed expression. So we added 2 there. I can't remember if I added enough to there, and we'll try just 1. Do we need to free anything? Nope. And nope. And this is when we're printing an expression. So when we print an expression, I guess this break is not kind of what I want. I want this sort of thing. But that will be expression.type, and then there will be an expression, and then could have just done the spin ops and then expression, and then do that same thing, but do it everywhere, and then this expression, do something like that. I hate that break. Seems like it would kind of hide things. Expression, but we do have like a lot of different things. So when we have one of these or one of these, not that, that things, I just want to print out, guess just the I kind of want to do one per each. Nah, because it is a span. Can we? Yeah. So when we do the span, this is prints like the whole works. But we can do an if printf. And what we print to it is just a string view format, and then string view args of the expression dot span, and then that's what I want to happen for those 2 things that I just added, so I can just add them. When we are making an expression from a computed expression, so this is when we have when we're doing like an assignment, we would have so say if we had something like this, when we, and this can be anything really, when we use that AAAA, this is, well, when it gets assigned, it computes that and then stores it as an expression that you then compute again when you like computing the next expression where it's used in. So something like that. And so I think for this, I don't really want these tokens to get bound back, because I feel like, but like perhaps I do want it, because like it could be useful to say that that's 1 and then BH is actually like 3, and we do in that kind of order. And these are L's. So like perhaps you might want to have that sort of thing. I don't know. It's made me think a bit more, but it's reasonably cheap to kind of return the right thing. So if we had a computed expression of an 8-bit register, we just have a type of a x86 8-bit register, and the ret.reg8 is going to be the expression.reg8, and we can just copy that and change a that can be 16 there, and then reg 8 can be reg 16. Something like that, and so then we can say we handled them. So when we're going the other way, that's reasonably simple. I'll just yoink this and take me back to it, and then here I want to do I can do something like this, and yeah, that's actually kind of handy. And then just do that, and it'll just kind of magic out. And so we handled them. So this is when we're parsing the expression. So we've now got these expressions, so I'll just do a token added up. So I guess when we want to do this, we have something like that, and this is x86, so that sort of thing, and then we can do like that, and oh, we don't have that, but do we have? Yeah, that's all good. Yeah, and I think here we do token.reg 8. The token will have it as well, and then we can do something like that there. So this is when we're kind of seeing whether it's a binary operator that you might want to take into account. And so in this case, take me back there. I can just, there's nothing we need to do. This will probably blow up, but that's all right. We can kind of deal with that when it blows up. When we compute an expression, yeah, we do need to do a thing here. We can just use this. So x86, that one, and then we can do that one, and then that function that we did before kind of just did it. These don't really require anything different because it's kind of stored in the tagged union, whereas binary operator, unary operator, and whatnot do need to kind of have something a bit different. So this is when we have a dollar. All right, so when we have a dollar, I feel like there's no reason to do this extra switch. Yeah, we're doing a switch on that, and we get expression dollar. Yeah, this adds nothing to it. What I might do is do that, and then we can do that and that. Have some things because we already know what it is. I think that's when I was doing double dollar as well in this one, but that's been handled a different way. So this is when we're seeing if we've got like a comma, like a list type thing. So don't need to worry about it there. Here, we should never really have a token as an expression. So this is kind of where we can kind of set whether we can do this. So in here, when we're parsing the statement, we could kind of join in with the identifier, but that's more done on the other lower level. So in this one, we do kind of need to say how are we going to parse a statement with these two tokens in it. And I think we can kind of just ignore it, and then it'll go into this, and we'll just get unexpected token type. And it might tell us what type it is. This one, what are we doing? We are changing the number of bits. So if we had something like bits AH, what would we do? I think we would complain, which will happen by default. It will just do an unreachable, which feels fair. Perhaps it isn't fair, but we can do a nicer message. But the point is that it will now do something that will fail at that point that I can then add something. So this one, what are we doing? We're executing times. So we have now basically got something like times AH and then DB0, whatever. So what does that mean? That only really makes sense if you can do an assignment, so that doesn't make sense here. And so it should really be unreachable. So I think I've convinced myself. So what are we doing in this? We're executing DB. So what happens if we go DB AH? And I feel we can safely just bump that up and let it fail. And so this is move. Want to do something, move. So move was basically checking this. So I think we need to compute this destination. So the destination, I think we need to go ASN computed expression computed dest. And so that is just going to compute. So we pass in a config, and this is going to be the move and dest. I think we just call it that. No, we do actually call it destination. And maybe we can call it destination there as well. And then we kind of don't need to. I'll keep that in there just while I think about things. And then here we can kind of get this, and this can be a source, and we've got the source. So here we have that check, and I want to do the same check here, but this is computed destination, and that's that, and destination expression. And so this is now computed source, and the same thing there, and the message is the same. So at the moment, this is if computed destination dot type. We kind of need to see what the type of this is to start with. So switch. Maybe we can do something like that. And if we switch over this, and because we're switching over a type of computed expression, I kind of want to search for this keyword here, and we can unit that there. Might seem annoying, but it can catch out bugs. And I also want to have this default. In this part, I kind of want to make some macros that just make all of them for me in some way. But yeah, so if we have a ASM computed expression, that one, or that one, we might do something. And what other types might we have? Currently, that's all the types that we're expecting on the destination side. But yeah, it kind of means that we need to do something based on it here. And here, yeah, I think we can. It's kind of a bit gross, but in these, we probably want to do unique up there, and then like also grab this default. It's gross, I know, but that way we can kind of have that. And so we this is the computed source, and computed source, and same thing there. So we've kind of done a few things. Make sure we clean up memory and whatnot. We compute things. So this is now kind of not kind of set. Easy. So if we come back down here, we should have what happens when it was a number, and then we kind of want to do that chunk here, and do something like that. And here we know that we're in the 8-bit register, so we can kind of yoink out that and do that instead. And then we can, this is computed source, and we also have the destination, but we at this point we know we don't really need to do anything because these don't really require anything free, but perhaps in the future it will. So what we want to do now is in this, we kind of want to make that do the same thing, which is a little gross, but it is what it is. Except here we want to do these two lines because it is a reg 16. So that was instead of that, we can go up there and it will complain about some things, but that's all right. And so I think here now I can kind of get rid of this one down the bottom, and then here we can have a big switch. This should kind of return once it works out what types everything is. And as a safety thing, we still can't compile. We've done things there, we've done things there. This needs to be computed source, and that probably will take that, and the reg8 is going to be the computed source, not reg8. So it's a tag unit on that kind of gets followed through, and this is computed source. And perhaps I'll do a little search on that. It's just going to be that in all those cases. And this one is going to be the computed destination. Because that one was on the destination. Cool. Now what happens? So when we did do that, so here we need to do computed source.reg16, and that will just magically work. We did things here, did we? So when we're executing int, so int AH, does that make sense? I wonder if that is a thing that you are allowed to do. Int, can we do int, not that one, int n, right, so it was int n, I think, yeah, that one. It's weird that it didn't do it when I just did it. So we can only have an immediate, so I think this doesn't make sense to do anything. Was that just the same one? This is in the jump. So yeah, I kind of want to get rid of that search as well. So in the jump, what would happen if we have a I think you can do stuff like that. So in JMP, you can have a register in some values. So this, I think I'll just let it kind of fail. We'll come to implement jump with registers at some other point. For now, we'll just work on the move. So now it kind of goes through, and this is a good test. Does it kind of pass all the tests that it had? And what I might do is see whether some of this nonsense kind of worked. Did that just? Yeah, it did fail. Cool. I was like, oh, it should. So it fails in move. So we've broken existing behavior by doing that. And it tells us where. It got a hole as the destination. Huh. That is interesting that it got a hole. I will be honest with you there. See what this kind of gets up to. It's got a number. Do not care about numbers. This was in the mob. It's kind of interesting. I think the spans are not coming through. So 8-bit, when we do this, that is just when we're getting the token. So we kind of chop it off, check whether it kind of matches, doesn't have stuff afterwards. And if so, then we should get that sort of thing. So we can do debug. So DH. I don't know. There's some things. So it is parsing as x86 instruction there, but then this is just an identifier, and this is just an identifier as well. So I think this is so really, I know what the problem is. So if we find that token, if we find this token here, and it's something that I've kind of thought about. All these kind of things that are searching for strings in a sense probably could have a little macro to wrap around it, but they're just checking for the verbatim string and they're not really caring about case. And so I wonder if I want to chop left string like case insensitive, which makes it a bit more complicated, but it means you can do stuff like this. So if I did AH with big yelling, you see it did some different things, and it passed it as an 8-bit register, and then here it kind of worked out this DH, and then it didn't know quite what to do with that. I guess that's potentially a bug that we could fix at another point, but I think here ignore case, something like this. I wonder whether it should pass in stuff. Just check the thing. Yeah, that's all good. And that is all good as well. Yeah. Oh, I didn't book me. Cool. So, case insensitive in this string thing. And I think I want it for all of these things. And I wonder whether I macroize some things. Because we could define check string, and this is going to have a type of so we need a type of a thing for this. We can do something with that. We need a base. I wonder if we can kind of work this out. Max, and we also need the strings. And we kind of have to pass in a few things, but it makes this all a lot better. And then we can have the field. And so what this I'm imagining is going to do is it's going to do something remarkably similar to this. And in fact, we can probably just do something like that. Yeah. And then here, this will have a box. And so in here, we would call that we can call this thing, I guess. And so instruction we can just call thing, and if thing, and then this thing is going to be the field, which is on this we need to kind of have a token type. Can we just have then we can do something like that, and then this can be top type. Right, and then this is going to be our max, and then yeah, it's also going to be the max, and then what else do we need to do? This is going to be our base, and then this is going to be our strings, and that now lets us do stuff like check string. Then we do ASMX86 instruction type, and then we ASMX86 instruction none, ASM num x86 instructions. Then we had string ASM x86 instruction strings, and then we had the token type, and then this is scrolled slightly out of my way. Then we had ASM token x86 instruction, and then we had the field that this goes into, and this was just instruction. And then we can do something like that. It seems a bit weird, but here we can make this do all the things. And I wonder whether might make a macro that will kind of do this for me, because I've got a few of them, and it seems like it would do. So what we can do is we can check string. We had the first type there, so we can do that. Now the base is going to be if we find the equals, and then we can yank that, and then we know we were kind of 1 comma in, and then this is going to be the next thing. What I might do is delete the leftover thing there, because that's not used at all. And so here we need to find the less than, and then we can yank that, and then here we can just paste that and then put a little space, and this will work a bit better. And now we need to find the strings. That was down a few lines, and if we search for the comma, and then we can yank that, we can paste that, then we need the token type. We can potentially do this, and then that, and then that, and then yank that, and then probably go up to the top. That requires that I need to do that sort of thing. That's all right. Got to keep a lot in your head when you're doing these macros. And now you want the field type. So I think we can go down here and then probably just search for the dot and then yank the next thing. And then can that, yeah, that's probably a safer thing. And then here we can finish it off. And then here I can do something like that. Oh, no, I kind of want to undo that and then do that. And then start here and then end the macro and then just boom. It deleted it, didn't it? Interesting that it did that. You can. This is a little spooky, but you can kind of get the macro out there. Oh, is that like what it is fully? No, but I can do something like that. That's what the macro is. So what I can do here is all these deletes and whatnot, I can kind of perhaps not do any deletes. Yeah, I think I can just kind of get rid of that. And then here I can yank to lowercase q, and no, that's not what I wanted. we're now recording macro, we can yank to lowercase. Oh, I see what I'm doing. Yeah, yank to lowercase q and get the whole thing. And then just to check, we can print out the whole thing and it's the same thing. Cool. So what I think I can do now, that's a little gross, but if I run that again, it'll do the same thing. I think it's because I have a thing here. Yeah. That's frustrating. You like put in a little macro and you think it's just gonna work. Right. So just do it again. Start a new macro. So what we'll do is we'll check string. We'll just add that in. We'll do that. We'll get rid of everything there. We'll go down one. We'll find the equals. We'll find the next word. We'll yank it. We'll go to the end here. We'll paste it. Then here we'll find the yank the next word, paste it. Here we want to find the strings, find the comma, yank the next word. Here we want to find the token. So I think we can go here, go there, then find that, then yank that. Then do something like that. And then for the field, I think we can do a similar thing, but we find the dot. And then we do that and then close it off. Maybe do that and then do that. And then we start there. Oh, we're not doing the macro anymore. When did we stop? In a good enough time. Cool. And then we just do that. And I hope that kind of made it apparent why I spent an age doing that. And we can kind of clear up that. And so now all those lines are just that. But similar to kind of what I had before, but now what I want to do is after this point we can undef check string, and so this left string, if we go to our string view, and we should have, can we do that? Can we do that maybe? Yeah. So we should have this string view. And so I think I had some case compare. So we just did like a case before it. So oh, I don't know because I've got quite long things now. I kind of want this case, but where do I want it? Case chop. That's kind of how it is. So if that's the case, perhaps I'll do them all. Something weird happened there. Cool. So here we that we don't need to kind of do, but this we can Top left one, we don't care about. Top left, we don't care about. Top left char, and so I think we just want to do case there. Numbers don't make sense. So I think just these functions. Now, I also have the right ones, but I think I'm going to be lazy and not do it until I need it. But I also want to go back to that view because we now need to kind of create these functions. So if I go case chop, so if we search for this one, yeah, and then if we go back to where we were, can we not do that? Can we? We don't care about the numbers. So like there, and then after the number, we can dump that there, and then here we have this. Right, so what needs doing? First off, I kind of want to do that, and then we can do that, and just add that case chop to the start of them all. Cool. So now the case chop is just doing the exact same thing that it was. So if we so I guess like we do something like this. Do something like that, and then do something like that. And then this will be like to lower of this thing. Oh, and this I now need to kind of do an unsigned char. Otherwise, it is undefined behavior. And then here we can to upper, and did I get all the things? So if not or not that, then we return a thing. Cool. And so this one, is there a STI case true? There is a, so we can do this, just that, yeah. Okay, so what do we have? We have case MP. We surely have more than that. Right, so that makes it a little trickier to do this str true true. So what this is meant to do is search in the string for a character. And the problem is that this might have like uppercase and lowercase and whatnot. So I think what I need to do is get a str of search, and then and then like size ti equals 0. This then len and I plus plus, and if we kind of look at all this, so in here, if too lower of, then we'll probably need to make it an unsigned char. No, we can just do this. Search I equals view data, something like that, or to upper of search I equals view data. And if that is the case, then I think we want to do this return. Otherwise, we will get to this return. I think that's that. This is the one that we won. And so SDRN CMP, is there an SDRN case CMP? Surely there is. There is. So, case CMP, and that's all we needed to do. And then this one is the same. We case, and this one is doesn't make sense, I think. Yeah, it doesn't make sense. So what we do is we get rid of it there, and then we get rid of it there, and keep the extra thing. So now I think this will just magically work, and hopefully both of these will go to the 8-bit register. So if we do it once, we get 8-bit register on both, and if we do the uppercase as well, we still get it. So that looks good. So now we're getting somewhere. Perhaps I should kind of add that up. I did some other things as well. I've been like pretty lax with my commit history at the moment. I haven't actually released this as well, so what I was thinking was I could tidy up that. That does some things as well. Yeah, what is? I'll just leave it. I might tidy it up and make it look good from the get-go. Rewrite history, as they say, and just have a better commit messages, because I kind of like, I get in the zone and I just like write code, but then you end up doing multiple changes sometimes. Cool. So where did this get to? We can now see we've broken binary operators. Cool. This is interesting. So we can do that little test. A equals 0, B equals 1, dba plus negative b. And if we recompile that with the debug flag, we just get unhandled token. I don't know this unhandled token because it also, I feel like this should have been caught. I wonder, it's still in my thing, isn't it? No extra. And so, like, when we do a symbol, yeah, so the symbols, we don't want to do this. So, yeah. So in our view, we kind of don't want to do the, so we're just doing trimleft by string. No, we're doing case chop left string. When we do this, we do a case CMP, yeah, so that should be doing the right thing. But then, like, I wonder, I feel like I need to s.c, see what we have in here. So if we have So we probably want string.h and then strncmp of negative to negative. What does it equal? Sorry about that. I'll bring that back up to there, and then we can kind of see what printf of the yank that, and then do equals, and this will be D, I think, and then if we kind of get this all in the right place, and then here we just do that sort of thing. Yeah, that cool. And what is this compile to? Do I have a yeah? It doesn't like that for some reason. What do we need for this? We just need string.h. I thought that was enough. Str. What do we need for this? So we just need the size at the end, so the size can go at the end. And to make that accurate, I'll put the size at the end. And if we run that command, we see it is 0, which means that it should be equal in my view. So what I wanted is a few things. I want to be down here, so we can see that this unhandled token easy. That's a easy thing to fix if we say get this check string to not do the case chop, and if we do it again, does it still? Yeah, so it still doesn't do that. It's potentially something with this thing. So, what I can do, it's going to be like gnarly. There's a -e thing, and if we try and do that, we can temp.c. And so in this temp.c, this is kind of everything that kind of got done. So I can probably search for in fact, I can probably search for ASM token, and you see here it's kind of padded everything out into. So if we get 86, and I actually just want the symbol token. I missed it completely. Symbol token. So we have the symbol token. And is this where we do it? Yeah. So we should have a symbol type thing. Cool. We go from none to the number of things, and then we chop it and then hit the size. That kind of seems right. And then we set the symbol to thing. Yeah. Interesting. So what I can do is perhaps do some debugging. So like if detect of STV error of this thing, and like perhaps I will kind of output that as a string. And then this whole thing equals some kind of size. We can pass in the string of that thing, and then the size can just be token.size. And I'm kind of interested in what that outputs. So if we do this one again, you can see here it is going through, checking all the things. So I guess I need to see what tokenizer looks like. So this can be uh, just a single character, and we'll just put that single character, and that can be tokenizer dot data. This is kind of assuming that tokenizer has some things in it, so hopefully this doesn't crash. But what didn't it like about that? The tokenizer is a pointer, yes. You are correct, and yeah, so that is probably all that's needed. That can just go and do that thing. Cool, that gets a ASAN error, always good. But yeah, so this is going through, and we can see here that it is starting with a dot and goes through all the symbols. And we don't, yeah, so we do have this, and for some reason it's got B there. Right, so I see what's happened. It's because we've got something directly after, and we do this kind of extra check of is there something after it. So I guess what we could do is a boundary, and so if boundary, we can do that, and perhaps I can wrap that in there. Otherwise, we just do the break there. And then that means we kind of need to say we care about the boundary, we care about the boundary, we care about the boundary, we don't care about the boundary. That's what that's for. And then now if I do this, I think it should kind of tokenize that a bit better. So let's found that as a symbol. Perfect. Cool. And so, like, if I run the test, does it kind of fail? All this is to do that. I look away and I get a SAN error. Cool. So what is we doing? Kind of want to be on that one. So we can set this up. ABC equals 1 plus 1 dB AC and $1. And what does that do? Buffer overflow. That's probably because we're like trying to kind of point to the top of the list and this thing here. So perhaps run that again and no ASIN? Yeah, no ASIN. Perfect. So if we do that again, looking more promising. Goes through. It's getting kind of slow, the compiler. But yeah, so that's going through everything, and now it gets to the point where I'm trying to do things. It's still kind of failing on the first mob. So we have broken that. How does this assemble? Do we have a AO? No, we can just mob AO1. So if we do this, instruction, and then a number. Perfect. And that's a different error to that gets some unexpected computed expression, and this is kind of failing to. That's really bizarre. Does it like matter we're doing that? Is it because we're doing debug? Yeah, so if we don't do debug, then we do that. I think I want to fix up that debug. So if we kind of go back to here, where is it? 887. We go here. This is we printing the expression. I thought we kind of handled this. We kind of said that we don't care about it. So what expression? It's a whole. So perhaps with a whole, we can also it would just be yeah. So the expression type is identifier, but then that kind of gets converted into a whole. So hopefully now the debug kind of shows us more things. No, it doesn't. So the number, we can also kind of print out the string of it. Does this let me do it? So this is getting further, and this should hopefully have shown me the yeah. So it passed it as an identifier there. I wasn't expecting that. I think this needs to be something like this. Yeah, is that cool? Perhaps it needs a space weirdly. All right. Yeah, not sure why it's getting an identifier again. To test again, we surely had some things. Yeah, so this we had identifier again. We've lost our. Oh, I did chop left string. This one case chop left string. Oh, and this directives. This is prime for over here. And do I still have it? No, not quite. I keep overrunning Q because like that's what a macro is, but I guess I can just do it manually. Do that sort of thing, and that sort of thing, and anything token directive and directive. And do we care about boundaries? We do care about boundaries, so I think we did that. Up the top there. Is that I feel like yeah was a bit out of it in the loop. Cool. Slow test might just because I'm recording. I don't know. But yeah, we should fail on the mob still. I haven't done anything to fix. We get a different fail on the mob now. So this is still in that kind of first little thing. We didn't get the expected output. So does it give us what it is? It did. So it's AL 1 1. So if we do this, I think I know why that is. Reg 8. So reg, I don't know, how do we get this? Bit register. So in here we should have a none, and we need to kind of ignore that none. So when we get reg 8 out of the thing, at this point here, we do the reg 8 minus 1. So reg 8 equals a string, and we can xm x86 8-bit register strings of computed source.reg 8. Now I wonder if yeah, I think this is meant to be the destination. Yeah. This is the destination. I think I've already fixed the bug, and then here we that'll take me there. Now there, and destination. Make sure we get the right thing. And those were the only two. So now hopefully every test passing. Well, actually, not the ones that I've added, which are the new instructions that I'm trying to encode. I had to make a few changes, which made it take a bit longer, but it is what it is. Cool. So that's now failing at the right part that I kind of want it to. So we kind of look where we are, we're in execute mode, and we complaining about we don't know what to do with an 8-bit register, as we could potentially say like what it is, but I mean, it says it somewhere. No, so I think if we did something like that, they'll kind of complain, and then if we just run the test file that I kind of did, it will say it's on that point. So it's got past the AL. It doesn't care about that. It's just, I don't know what to do when that side's a register as well. And that's a good point to be in, because that means like I can now kind of go and, oh yeah, that's right, I jumped around a few times. Now I can kind of work out, well, is it that one, or is it the other one that I can do? This one. So if it's an immediate, I do this instruction. If it's a register, then I kind of do this instruction. But I could potentially do other ones, like I could detect whether it's this, if it's a memory, but I haven't done memory yet. So if it is a memory thing, how long have I gone? So an hour and a half. May as well do it. I think I can kind of get that out there. So if we have we're in the computed source type. If we have a ASM computed of an 8-bit register, just add a to do there just in case I compile. So this is after it's already got an 8-bit source, destination register, and now the source register is also 8-bit. So at this point here, I even kind of say how I expect it to compile. We can do this. can we do that and then that, and then and we can just run that one test. The benefit of that is that we can kind of do like maybe a split there, and we can do that, and maybe we actually we we can do a split like that and that. Yeah, cool. I did what I wanted to achieve with my window. So this is kind of showing me how I should encode it, but that's kind of how I could encode it based on the test. But I can also see with the TF as well. So the idea is I can test my one, test Phasm. It should end up as the same point. And you see here, it's kind of pointed out that to do, and it's pretty much sitting right here. So how do I print it? I don't need to check the bounds on it because it's just going to be what it is. So I think it's something as simple as this. So the first number is just going to be 88. And then the second one is going to be the mod, which is, well, we can say it's C there. And we're going to mod on the source. So that's the computed source.reg8. And we're going to shift that up by 3. And then we're also going to pour on the computed destination.reg8. And perhaps we should end that with 7. And perhaps we should end that with 7, just in case. And then that whole thing is what we kind of want to do. Golly, my stomach was just doing the biggest rumble. And I think I should do like some checks, to be honest. So like if computer destination.reg8 is equal to ASM x86 8-bit registers none. Perhaps that can get done at this point here. So if the destination is none, or the computer destination.reg8 is greater than equal to ASM num x86 8-bit registers. So if this is the case, I think I just want to do an unreachable. This seems like a case that shouldn't happen with the way I've programmed it. And now at this point, when we find that the other one is that we can then do the destination and replace it with source and do that. And I probably want a similar thing here. So this can replace the source with destination, but also replace 8. Can we do that? No, that doesn't pick up that. We can do that one, but we also need to do that one, 16B. And then here, and we don't have it yet, but we will have a. Perhaps we will leave it for when we actually have it, but who knows, I might forget. That's when we have 16-bit registers, which is not this one. It's down here, which is 89, so perhaps I could copy paste and just have an instant win. So we get this and we just print it out. So yeah, maybe I'll just yoink that there. We can do the 8B with 16B and do that everywhere. And we can also replace reg 8 with reg 16. Oh, this gets a little trickier though, because yeah, this is perhaps I wanted to see how this kind of plays out. So mine won't do it, doesn't know what to do, but TF does that. So it does C3. So it's got the C. The A is 0. So if I kind of do a C, that should be a 1 because B is like not there. And so here we can see that got a B. So I don't know what that kind of means. So yeah, that means that the source is kind of in the middle. So that would kind of line up with that. So this was 89, and it was just a single byte afterwards, which was the 16 bits, and the same way around is there actually. I think that's just perfect. So that should do that, and perhaps I feel confident enough that I could do some tests, but instead of those regs, I want these regs, and get it in this point. And here I would expect it to be 89. And the same thing, just the source test type thing. And so, like, maybe the test passed. And if so, I think now switch should return. So the switch did not return. It's kind of interesting that we had that switch should return, but it's pumping it here. That means in this, that's spooky. In this, no, this is. We do that, no, that seems legit. So it should just call this. Like to the I haven't saved. So I just put in the 16-bit code, but it didn't actually do anything. Right, so now it's hitting that switch. So I'm not returning at some point. So I think it's probably at this point here. And probably also at the 16-bit equivalent down here. And so now I think if I do this, it'll pass both tests. I'm saying I think it will pass the test, but look at that, it got somewhere. And this is in the 8-bit version, and it got the wrong code. So what did... let's get rid of that and then go back here. And then can we like do that sort of thing? And then like, are we allowed to do that? No, no, just give me a bit of space. I want to see kind of what was expected and what ended up. So it was with the 88. It expected C9, but we gave it C0. Interesting. And it was just with move AR. So I wonder if I can kind of see what that is. SM x86 8-bit register strings of computed source.reg8. So here we can go source equals, and then here we can go dest equals, and then here we can go destination, just to see like what that is currently looking at. But I do feel like I need to like run out the door and eat something very shortly. Cool. And what did it reckon? It reckon both was AL. Oh, this, yeah, I see what's happened. So this, I need to kind of wrap to the next space and that, and then -1 of it, and then do that. Um, I think that kind of screws up my macros, my surround plugin. But yeah, I think that's what my issue was. I was 0 -1ing and doing that, and same place. Just ignore me. I actually know this is in the 16-bit code. That means I just need to yoink that line and kind of come down to 16-bit version and just change the 16, and then this 89, it needs to be that to, yeah, just that change. Cool. Now I think it should pass all the tests, and then we'll finish up and go get some food to have some food. Looks like it's passing. Looks like it's passing. Where did it fail? It failed when I was trying to do this type of thing, because it doesn't know what to do. This when is executing a move and you've got hold. I thought I kind of made that work. Anyhow, the stuff I wanted to add now works, and most of the stuff before kind of worked, but perhaps some areas don't. It seems like it's trying to compile that. But yeah, anyhow, I will leave it at that, and I hope that has been kind of interesting to people, and like the process on how I might add a thing. So I kind of want to these two can get rid of, and it's just that one. Cool. Yeah, add them all again. So I'll add that as add mod rig maybe H and H, and that's all I did. Plus much rather clear. No way to push it yet. But yeah, hopefully that's been interesting to people. I'm having a little bit of fun doing everything, and I think at the moment I have broken my main build. Yeah, so it still doesn't know this. So that's basically doing memory addresses. So perhaps I'll now make a memory expression or memory dereference expression, and then that's kind of like a parenthesis, but stored a bit different. It's got an inner expression. You can pass the inner expression and do blah blah blah, and kind of work out where to put things. Could be kind of interesting when you have colons in the middle of this. Like, if I think I can do stuff like that, and like even and stuff like that, and to work out what it all kind of is depends on bunch of things. But yeah, hopefully that's kind of interesting. Let me know. Until next time, I'll see you. Have a good day.